right, so this is just a problem to identify which reaction is oxidized, which one is reduced. Right, and so if we're looking at it, right, so this is magnesium 0, this is oxygen 0, right, and then this becomes 2 plus, and this becomes 2 minus. And so then in that case, right, I always think of oil rig, right, which is oxidized is loss, reduced is gain. There's also Leoger, right, that you can remember, but I prefer I don't know. I just remember oil rig off the top of my head, right? So oxidation is loss of electrons. And so, right, so if you're going up in charge, you're going to be oxidized in that case, right? So this guy is going to be oxidized, right? The oxygen then is going to be reduced in that case, right? And so, a different way that you can think about it too, right, is like reduced means that you're going down in oxidation number, right? Oxidized means you're going up in oxidation number. Right. And then, I mean, again, same approach all the way through for all these different parts, right? It's just simply looking at what's going on for all the different parts and what's being oxidized, what's being reduced in these scenarios. I would say one of the ones that's probably a bit tricky to think about, right, is in scenarios like part D, right? So I'll just go through D, right? So if we look at D, we can see that the tin is going up in oxidation, right? So this guy is being oxidized. If we look at the chromium, right? So in this case right here, the chromium overall has it has 9 electrons in total, right? There's 7 oxygens, right? So the oxygens are all going to have a 2 minus charge, so that's 14. And then you still have an extra charge of 2 minus, so you can subtract 2 off of that, right? So then that means that between those two chromiums, you have to have a total plus 12 charge. And so you can subtract 12, right? Divide 12 by 2, and then you get 6, right? My question here for B8 is when we talk about oxidizing and reducing agents, is that the whole molecule or is that the specific atom? So when we're talking, so the agent is going to be the whole molecule. But within a molecule, only specific atoms might be oxidized or reduced. Right. So if we use right, C2H4 as an example, right. So if we look at C2H4 and O2 in this case, we know that the O2s, right, they're all going to be converted into O2 minus in those scenarios, right? And so the carbon, right, is going to go up to being a 4 plus charge, right, and that hydrogen is going to go to being a H plus charge, right? So the C2H4 completely on its own is all going to be oxidized, right? Because both atoms are going to be oxidized in those cases. In the case of the Cr2O7, 2 minus, the oxygens don't change oxidation state. The chromium atoms do, right? So the Cr2O7, right, in this case right here, you have 6 plus charges on those chromiums, whereas right here, right, you have a 3 plus charge. So technically, right, the chromium is being reduced in this case, right? Overall, though, the Cr2O7 2 minus, you would consider that to be an oxidizing agent because that molecule is the one that's transferring the electrons, but it's only the chromium atoms that are being, that are changing the oxidation state because the oxygen atoms are staying exactly at 2 minus, right? Those don't specifically change. And so that's the I would say the difference to think about is that the agent is the whole molecule, but you may only change the oxidation state of one atom as a part of that agent in those cases. Does that make sense? Okay, cool. Yeah. So right, so those are like the things to think about, right? So it may, like, for a lot of reducing agents, oxidizing agents, especially when you start going into like orgo and like inorganic and like all these other things, right? Oxygen, unless it's molecular oxygen, right, it's always going to be 2 minus. Very rarely, I think, do you ever find a 1 minus or anything like that oxygen, right? Because that's not favorable, as you guys hopefully remember from at the beginning of the semester and stuff like that. And that's why, you have those like rules in terms of like, oxygen's always this charge, right? Fluorine and chlorine and stuff like that are always going to be these charges and stuff. right? It's the same thing, right? With if we look at, part E in this case, right? So the iron in this case, right, is 2 plus. The sulfur right here is 2 minus. And but then if we go over here, right, to the product side, what happens? And then the nitrogen, right? So E is a very complicated one, right? So if we look at E, right, what we have then is 5 plus for that nitrogen. Right here now, that nitrogen becomes 2 plus. This sulfur becomes 6 plus, right? Yeah, right. This iron now is 3 plus. Um, in these cases, right? So all of those are kind of like moving all around the place, and stuff like that. And so, you have to think about what's going on, right? So the iron sulfur, or iron sulfide, in that case, right? Both of those atoms now are being oxidized, right? They're both gaining oxidation states, right? They're all becoming more positive. For the case of the nitrate, right, that's starting off at 5 plus, that's going down to 2 plus, right? That's going to be reduced. And so you would consider the iron sulfide to be the reducing agent. You would consider the nitrate to be the oxidizing agent, even though the oxygen in the nitrate, right, doesn't change oxidation state, right? It stays exactly the same. The only thing that's changing oxidation state is the nitrogen atom. But based off of that reaction, right, that's where you're going with that. Cool.